Now I'm going to take you through how to calculate the pCO2 from pH measurements and alkalinity measurements of seawater. At the end of the day, what we're really interested in is what particular CO2 level we're achieving in our experimental treatments. And so really that's what we want to be able to calculate from all this data that we're collecting. Now, in order to do that, I'm going to assume that you have done an alkalinity titration and the calculation as I showed you in a previous video, and also done a spec pH calculation as well. Now, really, those numbers can come from anywhere. They don't necessarily have to come from these calculations, but in this case, I'm going to assume you have done it that way. So, like we had before, the function that we're going to use is coming from the package carb. So if you haven't had carb loaded and installed on your particular instance, go back to the alkalinity titration videos and look there how to install it. And then the function that we're going to use there is called carb. So we can type that in here in the help window and take a look here at the parameters needed for carb. So one of the interesting things about carb function is that this is going to calculate the parameters of the seawater carbonate system. And one of the interesting things about the seawater carbonate system is there's a lot of different parameters, but you only need to know 2 of them, and then you can calculate all the other ones. But what that means is there's a lot of different individual types of those parameters that you could have measured and then calculate the rest of them. This function actually accommodates all those different measures, and so how it does that is it has this long list of flags that you give the function to tell it what parameters of the carbonate system that you are going to give the function in order to calculate the rest of them. In our case, we have alkalinity and pH, and so that actually turns out to be here flag 8, which is pH and alkalinity are given, and then it calculates the rest of them. So to begin this function, what we're going to do is we're going to type in carb and then start off with flag equals 8, because that is what we have. Now we have 2 arguments here, var1 and var2. This is variable 1 and variable 2. Now what we do is we enter in the variables in the same order that they're given here. So we give it pH first, and then we give it alkalinity. Now we stored our spectrophotometric pHs in the object pH, and we stored our alkalinity titrations in the or our alkalinity results in the object titration. So what I'm going to do is I'm going to give it first var1 equals pH. Now that's giving it, oh, I need a comma in there, that's going to fail. Now I'm giving it all of my pHs, all 7 of them. If you remember, we calculated more than one pH, and so we have 7 of them. What that means is this is when it calculates it, it's going to give me a different pCO2 for every pH that I'm giving to the function. So this should actually give me 7 different pCO2s, one that's corresponding to each of those pHs. Next, we give it var2, and var2 is titration, or the object in which we stored the alkalinity that we calculated from our alkalinity titration. Then we have a handful of other factors here. We have salinity and temperature. I'm going to take those from now salinity I'm just going to go ahead and take from one of my previous functions. So say the alkalinity titration. So really this is just the pH, or excuse me, the salinity of the seawater. We have used that a couple times before. So what I'm going to do here is I'm going to type in alk $S and bracket 1. We can run that here real fast and just see what it was. It turns out it's 27. Okay. And next up, we also have to give it temperature. Now, temperature here is a little bit different. In our alkalinity titration, we use temperature that the seawater was held at in the jacketed beaker in the titration assembly. That is what we gave it. And in the spectrophotometric pH, we gave it the temperature at which we equilibrated the temperature at before we ran the absorbances. It's actually the temperature that each of those fluids were at when we ran the test. Now, for the carbonate chemistry, we want to know what the temperature is in the tank. So what you should do is when you take these parameters, you should make note of what the temperature is in the tank. That should be just up on the digital readout on the pH stat boxes that are on each of those tanks. And so I saw lately we're running about 25.3 degrees Celsius, so I'm just going to put that in there. So again, this temperature is slightly different than the previous ones. This is actually the temperature of the tank. Okay, there's a lot of other arguments here, but I'm going to actually leave all of those blank. We're just going to take the defaults with those. We're not going to worry about them, and we're going to run this as is. We'll take a look at what we get. And so what we have back here now, expand this so we can see this, is actually a lot of different parameters here. So again, I have 4 rows, and 7 rows, and each one of these rows corresponds to one of those pHs that we gave it. So we got a different calculation for each pH. If we go along here, it gives me back the pHs, but also gives me the CO2 concentration, for instance here, the fugacity of CO2, the pCO2, this is what we're interested in here, but then a lot of other things here as well, like the concentration of bicarbonate, the concentration of carbonate, the dissolved inorganic carbon, the alkalinity, the omega aragonite, this is the saturation of aragonite. We also have the omega calcite, which is the saturation of calcite. So if we go back up here, what we really want is a pCO2. That's what we really want to get out of this. So how do we get back just the pCO2s and not the entire list of all of this long laundry list of all of the different carbonate system parameters? And how we do this, we come back to our function. And at the end of this, we type in $pCO2 with the P lowercase, the CO uppercase, and then 2. If we put that in there, it just gives us a string of pCO2s. And so there we go. We have a string of 7 pCO2s, each one corresponding to one of those pHs. And these are what you can then go back and enter into the carbonate chemistry logs for that particular day. So that's how you calculate the pressure of carbon dioxide, the partial pressure of carbon dioxide, or the pCO2 in our tanks, given the pH data and the alkalinity data that you have calculated from the spectrophotometric pH and the alkalinity titrations, respectively.